We're going to start talking about chemical calculations, which is really the heart of stoichiometry. This section will probably take us several days to get through, so don't worry if it seems like we're going fast, it'll be fine. So, if a plant wants to produce ammonia, but it doesn't want to produce too much because it doesn't want to have to store it, it doesn't want to produce too little because there'll be a shortage, so they have to be able to calculate how much they need to make at any given time. They also have to have the right amount of starting materials, etc., so they can keep production running. So we can use multiple ratios in chemical calculations that will help us predict how much we can make, how much we need to start with. So a mole ratio is a conversion factor. Yes, we're back to conversion factors. It will be fine. You remember this. You can do this. And they come from a balanced chemical equation, and they help you understand the terms or the amounts of each type of substance you need in quantities of moles. So chemical calculations, the heart of it or the center of that calculation is always going to be a mole to mole ratio. And that comes from the balanced chemical equation. It could be a reactant to a product, it could be a reactant to another reactant, or a reactant to a product to a reactant. So you can use anything on any side of the equation. So here we have N2 plus 3H2 give us 2NH3. We can write actually 6 ratios if you think about it. Each one of those could be inverted, and we could have 1 mole of N2 over 3 moles of H2, or we could have 3 moles of H2 over 1 mole of N2, etc. I don't need to read all that to you. You're smart guys. The mole ratio always has to have what we want to cancel in the bottom or in the denominator. And if we do that, then we will correctly calculate. And so it's just like the other calculations we've been doing before, where whatever we're given, then we put in the next box at the bottom, the denominator, the thing that we're given, and we proceed through. So I will have lots of problem videos that you'll have to watch in addition to the lecture videos for this section. So how many moles of NH3 are produced when 0.6 moles of nitrogen react with hydrogen? They don't tell you how much hydrogen you have because you're expected to have as much hydrogen as you need. The limiting, or the one that we're interested in, is nitrogen. So we'll need our balanced equation. Our known is going to be 0.60 moles of N2. And that's our given. What we want to find is moles of NH3. So the mole to mole ratio, if we go back to the equation, we're going to have to find N2 to NH3. And so it would be 1 N2 to 2 NH3s. And we have to put it in such a way that the N2 will cancel out, so the N2 has to go in the denominator. So when we write it out, we have them lined up so that they'll cancel out, and we get that it would be 1.2 moles of NH3. This is very simple, and I think you're thinking, well, duh, I knew that. It can and will get more complicated, I promise. We always start easy, and we work our way up to harder. So it's a 2-to-1 ratio, so we do expect it to be twice as much NH3 as N2, so that makes sense. And in the lab, the amount of a substance is usually determined by measuring its mass. We don't normally just do moles to moles. We usually start with grams. And I'm going to stop here for today. I know it seems kind of short, but I want you to make sure you've read this part. And I'm going to do a couple of calculation videos with just multiple ratios, show you how I want it set up. And so probably tomorrow, Wednesday is a working day, not a free day. You'll have several calculation videos to watch. Each one will be very short. It won't be too difficult, but we're going to stop here so that we can make sure we understand how to do multiple calculations. Thanks for watching.